Hi guys, today we'll be learning on quadratic equations, and in this video we'll have a brief introduction of what is quadratic equations and what equations are called as quadratic equations and what equations are not called as quadratic equations, how quadratic equations are derived from polynomials, and what are the real-time examples of quadratic equations. So before we jump on into like quadratic equations, first we need to understand what is a polynomial. So polynomial. See, polynomials are nothing but, let's assume that you have a function in x, like in the form of, it could be any form like x cubed plus x squared plus x plus 1. Then I can say that this whole part is nothing but a polynomial. Got it? When you equate something, like this f of x to 0, then it will become some equation. So what is the name of the equations and all? We'll be learning now. So let's assume that you have a polynomial of f(x) which has x squared plus x plus 1. See, I can say that this is a quadratic polynomial. Why? Because it has like a degree. It has a degree of 2. So degree is what? 2. So a 2 is nothing but it's a quad actually. So that's the reason it is called as a quadratic polynomial. But what is quadratic equations? When a polynomial of degree 2, that is x squared plus x plus 1, is equated to 0, it is called as a quadratic equation. Understood? So when a polynomial of degree 2 is equated to 0, then it is called as a quadratic equation. So a degree 2 polynomial is nothing but a quadratic polynomial, and a quadratic polynomial is equated to 0, then it is called as a quadratic equations. Got it? So this is the this is how the quadratic equations are derived from the polynomials. Now try to understand. Now let us understand the standard form of a quadratic equations. A standard form of quadratic equation will be in the form of ax squared plus bx plus c is equal to 0, whereas a, b, c are constants, x is variable, and the degree here is simple, it's 2. Got it? So see, when you have a quadratic equation, it should be of this form. If any one is missing, or if you see any sort of like discrepancies, then it is not a quadratic equation. So let's see what are the things that are not quadratic equations. Examples. See, these are the examples. So when you have something in the form of like root x plus x squared plus 1 is equal to 0, sorry, this is not a quadratic equation. When you have something called x to the power of 1 by 3 plus x plus 1 is equal to 0, then it is also not a quadratic equation. See, when you have something, the radicals of root, so radicals are nothing but it's a root actually, and when you have something like a decimal numbers or some real numbers in the form of p by q, then it is also not quadratic equation. And and when you have the exponent has minus, then yeah, it is also not quadratic equations. So what are the things that I wrote it in red? These are not a quadratic equation. So the basic rule should be this: x square plus bx plus c. So you have it out. So whether this can be called as a quadratic equation, x square plus 1 is equal to 0. Is this a quadratic equation? Yes, it is a quadratic equation. Why? I can rewrite this in the form of x square plus 0 into x plus 1 is equal to 0. Here a is equal to 1, b is equal to 0, and c is equal to, yeah. So this can be a quadratic equations, guys. So please don't get into a confusion that since there is no the value of px, so it doesn't mean that it is not a quadratic equations. So blindly remember that if I have a radicals or the exponents like this, radicals like this, or exponents like this, or in the form of the negative numbers as well, then those are not actually a quadratic equations. Now let's look into how exactly a quadratic equations would be in terms of graph. Okay, let me just rub this stuff. Okay, that's fine. Okay, so let's assume that you have a graph of x-axis and y, and let's assume that x square plus x plus 6 is the quadratic equation. When you rewrite this graph, you'll get something like this. Assume that this is some 2, and assume that this is something 3. See, actually it is not let me rub this stuff. A and this is B. Okay, whereas A and B are roots of the below quadratic equations. Okay, whereas this curve is nothing but x square plus x plus 6. So this is how the structure of the quadratic equation should be. But there is a lot of more information on this curve, what exactly are A and B, how they form, why exactly this is in the form of a bell shape or a parabola shape. See, all these questions I'll be explaining you in the later videos or something. Since it's introduction, I don't want to make it very big. So let's go into the the applications of the quadratic equations. See, this is the figure. Okay, so what this figure says is, I told you right, a quadratic equations will have the a shape of this way. Okay, this is the parabola curve. Let's assume that if you are a football player or something, if someone hits the ball, and it doesn't mean that it always follow the parabolic shape. Let's assume that it is following the parabolic shape. And if someone asks you, this is the point at which you kicked, okay, and this is the point where it got landed. And if someone asks you, what is the height of this? This is the point at which you kicked the ball, and this is the point at which it got landed. Someone asks you, what is the height of this ball above from the ground? So these sort of calculations and all, you can always measure it. And if someone asks you, what is the distance between from start to end, let's assume that this is L. See, these values can always be found very easily by using the quadratic equations. This is one of the real-time applications of quadratic equations. as we solve more problems, you can try to understand you can understand what are the applications of it. And there is a separate video I'll be creating for you, and we have for you where it says that what are the applications of quadratic equations. And thank you, and I will see you in the next video. Have a good day, guys.